In this video, we're going to look at the quadratic formula, and in particular, we're going to look at an expression called the discriminant. So to begin, let's just note that when a quadratic equation is of the form ax squared plus bx plus c equals 0, we can always find its solutions by applying what's called the quadratic formula. And the quadratic formula is written below in that box. And we're going to be using that soon, but for today, we're going to focus on just a part of it, which can give us information about the number and types of solutions that this equation has. So that expression b squared minus 4ac that I've highlighted is called the discriminant. That can be used to determine the number and types of solutions to the equation. So let's take a look at the discriminant in more detail here. And what I've done is I've kind of organized the situation into a table, but in a minute we'll take a look at a Desmos animation to get a more dynamic view of what's going on. So once we have our quadratic in standard form and we can identify a, b, and c, we can compute the discriminant. So I'm going to call the discriminant d. If you get a positive number when you compute the discriminant, that means that there are two real roots. Now, for our purposes, you can think of the word roots as meaning x-intercepts. All right, so roots for us means x-intercepts. So a positive discriminant tells us there are two real roots or x-intercepts, and so graphically the behavior of our quadratic would look like this. Notice that it intersects two places, the x-axis. If the discriminant is 0, on the other hand, that means that there would be one x-intercept, which means that our quadratic would behave like that, in such a way that it would touch the x-axis just once, namely at its vertex. So that would be the case when there's one real root or one x-intercept. And the third possibility is that your discriminant is negative. If that's the case, you get what are called complex roots. And although this course isn't going to focus on that, one thing you should notice is that if that's the case, that means there are no real x-intercepts. And so your quadratic is sort of floating above the x-axis. It doesn't intersect the x-axis. So I'm just going to kind of note here that this parabola doesn't intersect the x-axis anywhere. Okay, it has no x-intercepts. So the discriminant can essentially tell us which of these cases we're in, even if we don't have the graph in front of us. For a more dynamic view of this, let's look at a Desmos animation here. So I want you to focus your attention first on the discriminant down here. I've got it kind of in such a way that I can scroll through some values. And notice the behavior of the graph and just compare it to the value of the discriminant. So let's start in a situation, for instance, where our discriminant is positive. So I'm just changing the c value, but in general, whenever my discriminant is positive, what's going to happen is it's going to yield a parabola that intersects the x-axis twice. If my discriminant is 0, as we see here, it intersects just once. And if it's negative, well, it doesn't intersect at all. So hopefully that visual helped you to sort the three possibilities. And what we're going to do now is we're just going to compute the discriminant and see if we can figure out the number and types of solutions just from the equation alone. So this says, given the following quadratic equations, find the discriminants, and then use your answer to determine how many roots the quadratic has. So we remember that our discriminant has the form b squared minus 4ac. So we look at our equation here, and we notice that our a is a 1, our b is a 6, and our c is a 9. So our discriminant would be b squared minus 4 times our a, which is a 1, times c, which is 9. We simplify this. 36 minus 4 times 1 is 4. And this becomes 36 minus 36, which is 0. So our discriminant is 0. It then says determine how many roots the equation has. Well, as we saw, when the discriminant rather, is equal to 0, well, that means that there's one real root. So we write that. Let's try one more. Again, we remember that our discriminant formula is b squared minus 4ac. So in this case, I see that my a is a 1, my b is a 6. Now, again, there's no constant term. That just means that there's really a 0 there. So my c is a 0. And so now we compute the discriminant. D equals, our b is a 6, 6 squared minus 4 times 1 times our 0. This is going to equal, well, that's 36. 4 times 1 times 0, well, 0 times anything is 0, so this is just 36 times 0, which equals 36. So our discriminant is positive. So if our discriminant is positive, that means there are two real roots. Okay, graphically, again, that just means your parabola would intersect the x-axis twice. Let's do one more example on this skill presented as a multiple choice. So this says, given the parabola, find the possible discriminant. So it says, based on the graph, what could be the value of the discriminant? So we're not given the equation, we're just given a parabola, and we are expected to figure out, based on how it's situated, what the discriminant could be. So I'll give you a second to maybe think about it, or you can pause the video and try to reason what it should be based on these three choices. And assuming you've done that, we can circle the right answer. So I inserted a little cheat sheet here to remind us that when the discriminant is less than 0, that is when you get a parabola that has no x-intercepts. So the only option here that has a negative discriminant is B. So that must be our answer.